can start. Okay, so week 3 of Python. So today we're going to start off with importing in Python. So sometimes we can import code that has already been written by other programmers and utilize them in our own programs. And in order to do that, we import things by writing import and then the name of the library. And we do this so that way it saves us time and lines of code when we're making more complex problems. If we look to the side, the first picture, or really both pictures, have import math, and you can do things like calculating the area of a circle, or like doing things like getting the square root of something. And all these things do is just save us time rather than us programming very simple things. We can focus on more complex programs. So other than math, we have import random. And random allows us to do activities that require randomization. So things like picking a random number within a certain range, flipping a coin, shuffling elements in a list, etc. It's really difficult for us to do this ourselves. So we're going to use this library. Yeah, and so you just do import and then random. And then every single function that you use from the library, you just do random dot, and then you call the function, and then you put in your parameters if it requires. So here we have an activity, which is number guesser. We're going to create a program that will generate a random number from 1 through 10, and then take a user input for the user's guess of the number, and then check whether that guess is correct. And for reference, to create a random number from 1 through 10, we use random dot rand and then int, and then inside the parentheses we put the numbers that we use, 1 through 10. I guess we could do this here. Oh, this is stuff we did last time. All right, so we're going to generate a random number, and let's start with that. Generate a random number. So we're going to have x equals, and then random, which is, oh, well, we have to import the library first. It's not already here. So import random. And we do random dot rand int from 1 through 10. And what I did was I assigned it to a variable x. And we're gonna take user input for the user's guess of the number. You guys could do that, but it's gonna take some time to just check it. So I'm just gonna print out x so you guys can see so first time it's 10, second time it's 8, second time it's 6. So if you create a program with that, you would just take in the value, and then you'd compare it using a Boolean expression. And then if it's correct, then you'd print out it's correct. And if it's not correct, you would print out that it's not correct. So let's keep going. So this is another program that you guys could do. It's we're gonna play rock, paper, scissors game. Choose choose the program's move with a random number. So you would pick a number between 1 through 3 that would correspond with each move, and then prompt the user for their move. And then you compare your answer to their answer, and then you would see if they win or lost. And then you might want to create a chart with the possible combinations, because I think this could get kind of complicated. And you make sure to print out the result of who won at the end. And this is import math. So what happens when you import math? The contents of the Python library can now be used, the Python math library can be used in your program. So some common functions that you could recognize from the math class is math dot sqrt, which is just short for square root, and it returns the square root of n. And then you have math.floor, which returns the greatest integer less than n. Then math.ceil, which returns the last integer greater than n. Math.pi, that returns the value of pi. Math.pow, xy returns x to the power of y. Math.degrees, n, which converts n radians to degrees, and math.radians, which converts n from degrees to radians. So here we have an activity that you could do, which is creating a program that will take the user input for the radius of a circle and then ask the user whether they are using degrees or radians and accept an angle measurement. And to add an extra step, convert the radians if the user enters degrees, or calculate the straight from degrees. Some math right here, guys. And then calculate the arc length from that circle and angle measurement. And then think what functions from the math library you would want to use. You'd want to use math.radians, math.degrees. Let's go back to these functions. And what are things? Yeah, just math.degrees and rand. Okay, Boolean. Femi, do you want to take it away?
Okay. So now we have Booleans. Next slide. What are Booleans? Booleans represent one or two values, which is true or false. In programming, we often need them to, if an expression is true or false. We can evaluate any expression in Python and get one of the two answers, true or false. So basically true or false. So these are like some real life examples. So like a light switch can either be on or off, so like true or false. And then you want milk in your coffee, yes or no, so true or false too. Yeah, logical operators. Okay, what are these? So these are and, not, and, or are Python logical operators. Logical operators are used to combine conditional statements. So and returns true in both statements. If both statements are true, not reverses the result, returns false if the result is true, and or returns true if one of the statements is true. Next slide. So these are like some signs, I guess. So the first one is an equals to sign. In coding, I think in general, you use two equals to signs, not just one, to represent equals, like a number, if a number is equal to another number. So like these are some examples of equal. So 1 is equals to 3, which is true. Then the exclamation point and an equal sign means not equals, and then 3 not equals to 4, which is true. And then you have the less than sign, and 5 is less than 3, which is false. You have the greater than sign. 6 is is greater than 1, which is true. Then we have the less than or equals to sign, which means so like an example is 4 is less than or equals to 4, which is true. Then greater than or equals to, an example is 7 greater than or equals to 10, which is false. Sometimes we want to combine the outcomes of two events. We can do this with an and or not operator. 0 represents false and 1 represents true. Think about these words in real life. So like these are some like truth tables. So like, yeah. These are also like truth tables too. So like true is 1. So yeah, true is 1. So true, 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 false, 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 false. I think this kind of like confusing. So like, yeah.
Yeah. So just to add on to what Femi said, these basically talk about truth tables, You take A as a value, B as a value, and Y is the answer. And so if you have an and truth table, if you have a 0 and a 0, it ends up with a 0. Or let's just work with trues and false. If you have true and true, then it's true, because when it comes to ands, both the values need to be true in order for the result to be true. If one of the values is true and the other is false, then the result is going to be false. If both of them are false, if both values are false, then the output is also going to be false. So if you have true, true, then you end up with a true. A true and a false results in a false and a false results in a false. In the or truth table, a true and a true is equal to true, because in ors, you only need one of the value in order to be true. So if you have a true and a true, it's true. If you have a true and a false, then it's true. But if you have a false and a false, then it's false, because it's or. And then the not just takes the opposite of whatever the sign is. So if you have true, then not true is false. If you have false, then not true, not false is true. So those are some truth tables. And thank you so much for sticking around this week. We hope you enjoyed it, and we hope you show up next week.